Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is matrices. This is an introductory video on this topic. Now question come, what is a matrix? Now let us consider one example. Let there be two students, Geeta and Ram, and they have these respective pen, pencil and books. These are the numbers given here. So Geeta has 3 pen, 2 pencil and 1 book. Similarly, Ram has 2 pen, 3 pencil and 2 books. This can be written in a matrix form like this: 3 2 1 and 2 3 2 and closed by a square bracket. So that is why a matrix is a square rectangular array of numbers written within square brackets in a definite order in rows and columns. So you may be wondering, can we put Geeta and Ram in columns? Yes, you can put. We can put here. We can put Geeta and Ram in column also and write the corresponding numbers here like this: 3 2 1 2 3 2, and this can be pen, pencil and book. So this can be written in matrix form like this: 3 2 1 2 3 2. So depending upon our convenience, the matrix can be written either in row format or in column format like this. This is the basic definition of matrices. But why we should do this? What is the advantage of writing in a closed bracket like this? That we'll see further, because it helps in simplification. We'll see that later. Now next we come to the definition of order of a matrix. Order of a matrix means the size of a matrix. Here we have taken the previous example and we see that there are two rows. This is row 1 and this is row 2. And similarly here it will be column 1, column 2 and column 3. So this particular matrix has 2 rows and 3 columns. So typically the order of a matrix is written as m into n, where m is number of rows and n is number of columns. So for this particular case, the order of matrix is 2 by 3. We call it as 2 by 3. 2 by 3 matrix. Now you may be wondering, how many elements are there? If we multiply m into n, we get total number of elements. So total number of elements in this case will be, total elements will be 2 into 3, which is 6. Now we'll come to notation of a matrix. We write a matrix by a symbol A and write it like this: Aij. That's what is written here for a m into n matrix, where Aij are the elements. So the first element will be, we'll keep I equal to 1 and vary j. So the first element will be A11, A12, A13, and the last element will be A1n. Second row will be A21, A22, A23. So these are rows, ith row and jth column. It is written like this. Now we need to construct a 2 by 2 matrix A equal to Aij, where whose elements are given by this. We need to find that. So the 2 by 2 matrix A will be A11, A12, A21, A22. We'll substitute now. A11 will be 1 plus 1 the whole square by 2. 2 square 4, this will be 2. Similarly A12 will be 1 plus 2 the whole square by 2, 3 square equal to 9 by 2. Similarly, A21 will be 2 plus 1 the whole square by 2, which is 9 by 2. A22 will be 2 plus 2 the whole square by 2. 2 plus 2 is 4 square, 16 by is 8. So the matrix will be A11 is 2, A12 is 9 by 2, this is 9 by 2, this is 8. Now there are different types of matrices like column matrix, row matrix, square matrix, diagonal matrix, scalar matrix, identity matrix and zero matrix. We will discuss this. Column matrix means which contains only one column. We see here matrix A is A4, where A is some constant or some variable. It can be written like this, but it has only one column. Similarly, B matrix has only one column. Similarly, C matrix has only one column. So this is the column matrix. Similarly, we have a row matrix. If a matrix has only one row, it is called a row matrix. So A is having one row, B is also having one row. So this is a row matrix. If the number of rows and columns in a matrix are equal, the matrix is called a square matrix. So in this case, we see this matrix is a 2 by 2 matrix, 2 rows and 2 columns. This is having 3 rows and 3 columns. So this is called a square matrix. Generally it is written like this: 3 by 3 matrix, 2 by 2 matrix. So these are square matrices. Both are square matrices because they have same number of rows and columns. Now what is a diagonal matrix? Diagonal matrix are having numbers only in the diagonals. All other numbers are 0. So this is written like this: Aij equal to 0 when I not equal to j. So Aij equal to 0 when I not equal to j. So all when the diagonal elements are there, Aij is not 0. Otherwise it is 0 throughout. So it is a diagonal matrix. Scalar matrix is a diagonal matrix whose leading diagonal elements are equal to, it's called a scalar matrix. So we see here, let us see here. So we see that this is a diagonal matrix first, yes, this is satisfied, and there the numbers are equal, all the diagonal elements are equal. So it is a scalar matrix. This is a scalar. This is also diagonal matrix and they are equal, it is a scalar matrix. These also diagonal elements are equal, and so it is a scalar matrix. Then we have a zero matrix or the null matrix where all the elements are 0. So here we have given example A, B, C. So this is a 2 by 2 matrix, this is a 3 by 3 matrix, and this is a 2 by 1 matrix. So all are having 0 elements. This is a 2 by 2 matrix, this is a 3 by 3 matrix, this is 2 into 1 matrix. All the elements are 0, so it is a 0 or null matrix. Next we have the identity matrix. Here diagonal matrix whose all diagonal elements are 1. So we see the diagonal elements as 1 here. Similarly here also all the diagonal elements are 1. This is a 2 by 2 matrix. This is a 3 by 3 matrix. So it is a diagonal matrix with all diagonal elements being 1. It is an identity matrix. Equal matrix. Two matrices are equal if they have the same dimension. If they have the same dimension means same order or same size, and the corresponding elements are equal. Let us see A and B. So first thing, if they have to be equal, they must be of the same size or same order. This is a 2 by 2 matrix. Yes, this is also 2 by 2 matrix. Let us check the elements: 2, 2, 10, 10, -5, -5, and 6 and 6. So it is of the same order, matrices are of the same order and the elements are same. So A is equal to B. Let us see A and C. This is a 2 into 3 matrix. Although we see that some of the elements are same in this A and C, but their orders are not the same. So it is not the equal matrix. A is not equal to C. Now, what is addition of matrices? Matrix can be added provided they have the same order. So let us see 2 by 2. This is also 2 by 2. Yes, if they have the same orders, they can be added. How to add? We'll add the corresponding elements, like 2 will be added to 5, 3 will be added to -1, 3 will be added to 5, and -6 will be added to. So this will become 2 will be added to 5, 7, 3 will be added to -1, 2, 3 will be added to 5, 8, and -6 plus 5 is -1. Again, this is a 2 by 2 matrix. So matrix can be added if they have the same order, and then we add the corresponding elements, and the resultant matrix is also of the same size. Similarly, we can do subtraction here, like -5 -6 will be 5, -1 -6 will be 5. Similarly, 3 -1 will be 4, -3 plus 6 will be 3, -6 4 will be -10. So this will be the subtraction of two matrices. Now, commutative law of matrix addition holds if A and B are two matrices of same order, then A plus B is equal to B plus C. So it can be easily shown. We take this matrix A, this matrix B, we add them, we will get 3 plus 1 4, 4 plus 2 6, 5 plus 3 8, 2 plus 1 3. Similarly, we can see here this also, B plus A, if we add like this B plus A, it will be same result. So we can show that A plus B is equal to B plus A. Now another important concept in matrices is scalar multiplication definition. What is scalar? If a matrix A and a scalar quantity C, the product is CA, means to multiply each element of A by the value of C. If we have a matrix A and we multiply it by 2, then each of the element is multiplied by 2. Here each element will be multiplied by this, 2 into 2, 2 into 3, 2 into 4, 2 into 5, 2 into 6. That's what we have written here. If 2 is a scalar, and 2a will be multiplying each element by 2, and the result will be 2, 4, 6, 8, 10 and 12. Now we see here important properties of scalar multiplication. It is associative here. Here we see A into K plus L will be Ka plus La, where K and L are some scalars. We take K equal to 2, L equal to 3 and A some matrix like this. Then we find A into K plus L. A into K plus L is 5. So 5 into A will be multiplying each of these elements by 5. We get this matrix. Now to check RHS, we multiply 2 into A plus 3 into A. That's what we are doing, 2A and 3A. Then we add them. We get this matrix same as this one. So we can say that A into K plus L is Ka plus La. So the associative property is valid with respect to scalars. Now we'll come to multiplication of matrix. This is slightly difficult. So the first condition is that if two matrices are given like M into N size and another one is given of size N into P. So these can be multiplied when the column of the first matrix N is equal to number of rows of the second. This is the first condition So this is n, this is also n. So the resultant matrix will be, from this we will get m into p, m into p. So two matrices can be multiplied if the column of the first matrix must be equal to rows of the second matrix, and the resultant matrix will be of the size m into p. Let us take one example whether it is compatible or not and check this. This is a 2 into 3 matrix and this is a 3 by 3 matrix. Let us see the columns of this. Column of this is 3 and the rows of this matrix is 3. So they are compatible matrix. So this can be multiplied. Let us see some other matrix. This is 2 into 3. This is also 2 into 3. So we see the second element, the columns of this matrix is not equal to the rows of this matrix. So these two matrices cannot be multiplied. Cannot be multiplied. They are not compatible. So how do we multiply? Let us apply the first rule here. This is 3 rows and 2 column matrix. 3 rows and 2 column, and this is 2 rows and 3 columns. So this compatibility is there. The number of columns in first matrix is equal to number of rows in the second matrix. So these matrices can be multiplied. So how do we multiply? We take the first row and multiply with the first column, like 3 into 1 plus 5 into 4 plus 5 into 4 plus 5 into 4, like that we have written 3 into 1 plus 5 into 4. Next we take 3, 5 and multiply with the second column, 3 into 2 plus 5 into 5. Next we take the first row and multiply with the third column, 3 into 3 plus 5 into 6. And similarly we repeat with the second row, multiply with all columns, third row with all columns, and get the final answer like this. We see that this is a 3 by 3 matrix. So when a 3 by 2 matrix is multiplied by a 2 into 3 matrix, the resultant will be a 3 into 3 matrix. You remember something like that, these two will get cancelled. So this will be, result will be a 3 by 3 matrix. Now the associate law is also correct here in matrix multiplication, like AB matrix multiplied by C is equal to A into B plus C. It can be easily shown with some examples. Leave it to the student. Another important thing, very important, is matrix multiplication is not commutative. Means what? A into B matrix is not equal to B into A. This is very important. Generally it looks like they must be equal, but it is not so. So let us take A equal to this matrix and B as this matrix. We multiplied them. So 1 0 will be multiplied by 5 into minus 5, 1 into 5 plus 0 into minus 5 will be 5. 1 0 will be multiplied with 4 and 1. 1 into 4 is 4. 0 into 1 is 0. So this will be made 4. 2 into 5 10. Minus 5 is 5. Now 2 into 4 8. 8 plus 1 is 9. And let us multiply B into A. B into A will give a result like this. So these two matrices are not equal because their elements are different. So we can say that matrix multiplication is not commutative. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.